Okay, this is lesson 20 in topic 2 of IM, so it's in rational functions, and we're talking about rational equations. So notice and wonder, anything you notice, anything you wonder is right. Just note this is focusing on denominators and solutions. So if you plug 2 in for these x's on both sides, you're going to have equivalent equation or expressions. They equal the same thing. Same here. You could notice that these two are the same, these two are the same. Are these two related? Actually, yes. Are these two related? Yeah, actually, yes. So just anything you notice and wonder is going to be right on that one. And that's going to lead us into what we start doing in this part of the topic. And I use cross multiplication. There are other ways to do it as well, but that's going to kind of gradually lead us in. In 20.2, I cannot really get my camera to angle where you can read everything all at once. If you are somebody who has printed like t-shirts or logos, or I'm trying to think, there are definitely other things that this works for that I'm just not processing right now. You are going to use what's called the average cost function. And your average cost function is normally C of X for cost. It's the fee, the overall fee that you're going to pay no matter how many you print, plus the cost per item. So cost per item times number of items. And because it's the average, when you think of finding the average of something, you divide by how many numbers you added together. So we're going to divide by the number of items. This number of items typically is going to be a variable. So you have a number plus a number times x divided by x. In this situation, this $35 just to set up their t-shirt printing machine is going to be our fee. It is $4.25 per t-shirt. So it's $4.25. We don't know how many t-shirts. And then we divide by how many t-shirts. So this is our average cost function. The average cost per shirt to print 25 versus 100, all you're doing is plugging in 25 for X and then doing it again for 100. So we have 100 over here. I would take this time, try to plug it into the calculator. If you have the nice fancy calculators, you can do it all at once and see what you're going to equal for both of those. Okay, I paused real quick just to get my answer. A couple things I want to point out. These 25s and these 100s are not going to cancel. Just like up here, these x's didn't necessarily cancel. In previous topics, we talked about writing it where your asymptote is written out in front or technically behind. So you can break this up and you would see one of two ways. You'd see 425 plus 35 over x, or you could see it in the opposite order. But those are different ways to write the same equation. This is how I leave it, but technically these are right as well, because this is going to be your asymptote, so the number you're going to get really close to. And that leads us into this. When you only print 25, it's going to be an average cost of $5.65 per t-shirt. When you print 100, when you put it in the calculator, you're only going to get 4.6. Because we're dealing with money, I would go ahead and add that 0 in there so you know it's $4.60 per t-shirt. The more you print, the closer you're going to get to being equal to just the material cost. Like that fee is eventually not going to be as, oh goodness, how do I word this? The more you print, the more worth your fee is, because it makes it worth it. If you only print one t-shirt, you're not going to pay $35 plus that $4.25 only to print one thing. If you print 100, that makes it more worth it. If you print 200, it might not even matter to you anymore, right? Because that average cost is getting so low. And that answers, this is why you read all the questions before you answer them. These equations up here lead you into what's the cheapest average cost per t-shirt you'll get. That's that $4.25. That's your horizontal asymptote, and you see that logic from right there. Okay, now this last question for 20.2, because they put it on the back where it's kind of hard to see. An average cost of $5 or less per shirt. We know that when you plug in 25, it costs $5.65. When you plug in 100, it's $4.60. So yes, 100 works. It is below 5. I had my students do it as close to 5 as they can get, and we know it's going to be between 25 and 100. A couple different ways you can do it. You can guess and check. 100%. You can take your equation that you know it's 35 plus $4.25 per shirt over your shirt. Or you could take that equation and set it equal to 5, because that's what I'm trying to get. This is where that cross multiplying comes into play, and you technically can cross multiply, or this is division, so you can multiply both sides by x. Again, you can cross multiply. Realistically, it's going to be the same just with how this fraction is set up, and we'll get more into cross multiplication later. But when you do the opposite, it cancels, and that just leaves you with what's up top. And 5 times x is 5x. What I want to do, because I don't have an x squared, I can just get my x's on one side and my constant on the other, combine my like terms, and then solve it that way. I do not like having a negative in front of my x, and I don't want to move my constant. That just makes more work for me, so I'm going to subtract this 425x from both sides. Again, the purpose of doing this is that this will cancel, and that just leaves me with 35 equals 0.75x. Again, if you know me, you know I don't really write that 0 out in front. To get rid of that 0.75, it is currently being multiplied by x, so I'm going to divide both sides by 0.75. And when I do that, I'm going to get 46.67 equals x. Now, here's the tricky part. Think about it. Can you print a partial logo? Do you want to pay for printing a partial logo? Is anyone going to buy a partial logo? Probably not. So you are going to round up. Even if it was 46.02, you would round up, because if you plug in 46, and I'm going from memory, so this might not be exactly right, you get like 501. If you plug in 47, you're going to get like 499. Again, from memory, this is just generally speaking. This is still over the $5. This is under. So when in doubt, you are going to round up on these. Okay, we're going to talk about some batting averages. So if you are somebody who likes baseball or softball, watches it, plays it, whatever, this is going to be your forte. If not, I will do my best to explain some stuff to you. So to find the current batting average, you take how many hits you've had. So he's had 24 hits out of 110 opportunities. Now, you do not have to be good or know much about baseball to know that this does not look like a good percentage. So when you do that, I believe you get a 0.218. Let me triple check that before I tell you wrong. Yes, okay, and that 1.8 is going to repeat. Now, we say like 0.218 in that field, or however you want to say it. They're going to say he's batting a 218. He wants to raise his average to 300. Again, that's really 0.3. Don't let that throw you. Don't lose your decimal just because of how it's pronounced. How many of the next consecutive at-bats will he need to raise his batting average? The trick is knowing that they're consecutive. So we want it to equal this 0.3. He's had 24 opportunities out of 110 so far, but we know that he's going to hit the next consecutives, and that's going to change his top number because he'll no longer have just hit 24. He'll hit 24 plus however many consecutive he's gotten. However, you also have to change this 110 because this is how many opportunities he's had. Well, he's also going to have that same consecutive opportunity. Okay, now this is kind of where the cross multiplication comes a little more into play. I'm going to put a 1 underneath here. If you're not familiar with cross multiplication, you multiply at the top, the numerator of one fraction, across the equal sign to the denominator of the other fraction. And then you do that same thing on the other part. Some people call it the butterfly. Now this one looks a little more like scissors. Sometimes when I draw it, it looks like a boomerang just because of how small this fraction is. So I have my numerator of 1 times the denominator of the other equals my denominator of 1 times my numerator of the other. And then I can go ahead and multiply, so distribute. So 0.3 times 110 gives me 33. 0.3 times x is 0.3x. And when I multiply by 1, nothing changes, so I can go ahead and get rid of that 1 and that parenthesis. Again, like we did previously, I want my x's on one side, my constants on the other. I'm going to subtract this 0.3x. And because I want to save space, I'm also going to move my 24 and I'm going to subtract it. If I were on my whiteboard or had pens or something, I might color code this to see or to help you see what's going on. This 24 cancels. 33 minus 24 gives me 9. Those x's cancel. This is where a lot of people get tripped up. This is like 1x minus 0.3. When you do that, it's kind of like 10 minus 3, and then you're adding a decimal here and here, which is going to leave you with 0.7x. This is being multiplied, so to solve, I'm going to divide both sides. And I really should have memorized these and or brought a calculator with me. Okay, we get 12.857. Now, this is batting. He can't hit 0.857 of a ball. He can't have that many opportunities. So again, we're going to round up and say 13. So he has to have 13 hits consecutively to raise his batting average to 300. Unfortunately, he gets no base hits in his next 3 at-bats. Okay, but he still wants to raise it to 300. So he still wants to reach 300. And if you didn't notice up here, I don't want to write 0.300, so I just stick with 0.3. They mean the same thing. Okay, so he has now had still only 24. He still needs to hit some more. What is changing is he's had 113 opportunities now because he had this additional 3. So he had 110. He's had 3 more now, still didn't make it. And then we're still adding. We hope that he can make some consecutive hits here. Again, with the butterfly, the cross multiplying, we're going across the equal sign. Again, cross multiplication is a shortcut because to get rid of fractions, you multiply by the denominator. And because you have 2 fractions, you'd multiply twice by the denominator. This is just saving you 2 steps, really. I had to think about it. So I'm gonna write it over here so I have more room. 0.3 times my 113 plus x equals my 24 plus x. I am not gonna write my 1 because that's not gonna change anything. 33.9 from 0.3 times 113. And then I just have my 0.3x. And I follow the exact same steps I did up here. So now might be a good time for you to review how to solve and pause the video to solve it on your own. Again, you can follow the exact same steps. There's only one number that's going to be different. So instead of just getting 9, I'm going to get 9.9. And that's going to equal my 0.7x. And then I still divide. And get 14.14. Except I forgot to divide on my paper. And this is a good example. When we learned rounding, normally anything under 14.5 you would round down, but again you have to round up because if he only hit 14 he wouldn't reach that 300, but if he hit 15 he would. So be careful with rounding. We are going to get more into cross multiplication, especially in lesson 22. And you will see more examples where it's not just a 1 underneath and why this cross multiplying saves you some steps. But for now, let's go do some practice problems. All right. A local office supply store charges $18 to set up their business card printing machine with the design, 15 cents in materials per business card to print. So we're going to see this in 2 different ways. My favorite thing is not just match the equation, but I write it on my own. So I have my fee, which is $18. I am being charged 15 cents per business card, and to find the average, I divide by that. So then I can find the one that matches, which is B. Now, previously, we were talking about how you can simplify this part because they both have an X, but you cannot break this down because you can break it up like this. And when you do that, your X's cancel, which leaves you with just 0.15 because X divided by X is 1, 0.15 times 1 is still that. And you can flip-flop the order, which I don't believe is how you see it, but these two are equivalent. Well, technically they're all equivalent. So that is this one. And that's why those two work. This one, it's flipped and you're not accounting for how many business cards you have. This one, you don't need the 18 in the bottom. This one, you forgot your 0.15 up top and didn't divide by how many there are. Okay, the school band, they give you the equation already. They still give you all the information, but you have $140 to set up the logo, 25 cents in materials per logo, and you have the equation given to you, which I believe you all could write on your own anyway. A and B are very similar in that you are going to plug in however many uniforms you are printing and then find the cost. Because it's cents and dollars, make sure you are rounding to the nearest 100th so that you have an accurate price. So you can figure those out. This is the one where you set it equal to your equation or guess and check. And then this one is your horizontal asymptote or your end behavior. I would pause it here because this is really good practice from what you did previously and figure out these answers. Okay, so a couple things. When you print 25 uniforms, it's going to be an average cost of $5.85 a uniform. When you print 100, it drops all the way to $165 per uniform, which is a pretty drastic drop. For C, they want you to do $1 per logo. So what I did first is I multiplied both sides by X to get rid of my X's here. This is a very shoddily drawn X. Okay, so that cancels, and I'm just left with 140 plus 0.25X. And then I am going to subtract this 0.25X from both sides. I think of this as if I have $1 and I get rid of 1/4, what am I left with? 3/4, which is 75 cents. And then I'm left with that 140. I didn't have a lot of room, so sorry, I'm jumping sideways, and I divide by the number in front of X. I get 186.67. Because this is how many uniforms have to be printed, I am going to round up to 187, and that's going to be my answer. Now, what will happen as the price of uniforms printed increases? It's going to go down, but this is your horizontal asymptote, your end behavior. The average cost per uniform will approach your asymptote, which is 25 cents. And again, that's because we can break this down. And honestly, how this question is worded really is just asking you, like, is it going to keep decreasing? Yeah, up until a certain point it will. So you could also say it will decrease. So the more uniforms printed, the less the cost. And I apologize, my cat is trying to break down the door. Actually, there's two of them trying to get into the room where I am hiding. All right, last practice problem. We have two competing sports equipment suppliers that are selling footballs at different prices. So we're going to do two different things. We have our supplier A. Their fee is $85, and then they have $2.59 per football, divided by however many footballs there are. And then B has a fee of $50 shipping and $4.29 a football. So they want to know which has the lowest average cost per ball if you buy 40. You're going to plug in this 40 with both of them. So 85 plus 259 times 40 divided by 40. Don't forget to plug in 40 for both of your x's. I'll do that with my b as well. And let's see what we get. Okay, so when we look at supplier A, when you put it in the calculator, you actually get 4.715, so you do have to round to 4.72. When you plug in 40 for B, you get 554. So A is your lowest average cost per bowl. And if you were to break it down and just look at the asymptotes, this would get down to 429. This one would get down to 259. So A generally is cheaper anyway, especially the more you the more footballs you order. Even though it has a higher shipping fee to begin with, this has a higher cost per ball, and that's what's going to show you your asymptote. So generally, especially after a certain point, A is going to be cheaper. We're only looking at 40. A is cheaper.